Okay, and so for homework 14, we are solving more quadratic equations, but we're introduced to this thing called the quadratic formula here. And I just want to quickly explain why the quadratic formula is helpful, because in the past we've been able to solve things that look like this by doing our AC method, where we said, okay, we're going to take 2 times 4 is 8. We're going to get all the factors of 8, which are 1 and 8, 2 and 4. And then we need a pair of factors that when we add or subtract them from each other, we get the middle term, which is 5. And as we can see, we don't have any of those. 8 minus 1 is 7, and 2 plus 4 is 6. And so I cannot get 5, which means that I cannot use the methods that we've used in the past to find the solutions to this quadratic equation. And what we've got is there's this thing called the quadratic formula that goes something like this. I'm actually going to pull it up here because I never remember the darn thing. I just don't use it often enough. So there we go. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay. And so that looks scary. I recognize that. Understand that it's really not that bad. There is a lot going on there, but as long as we are careful, there's nothing that we can't handle. And so remember that this is our A term, this is our B term, and this is our C term. All we need to do is replace the variables in the equation with those coefficients from the equation that we got to start with. So what we will have is x is equal to negative b, so negative and then b is 5, plus or minus. And the thing that's going to trip people up on this or make it difficult is mistakes with negative signs and that kind of thing. So be particularly careful of like that minus in front of the b and the minus in front of the 4ac. And so we've got b squared. Again, our b value is 5, so 5 to the power of 2 minus 4 times our a value is 2, and c, our c value is negative 4. And again, I think a lot of people are going to make the mistake of putting a 4 in there instead of negative 4. It's a common error. So those to me, I think, are the places where we're going to run into headaches. And then all of that is over 2a, so 2 times 2. Okay? Now we just need to simplify that, which is really not, like I said, not super bad. And so negative 5 plus or minus the square root of 25 minus 4 times 2 is 8, times negative 4 is negative 32. And again, I think it's those two negative signs next to each other that are going to cause problems for people. Be really careful with your negative signs with this thing. And then 2 times 2 in the denominator is 4. So if I simplify this further, negative 5 plus or minus the square root, that would turn into 25 plus 32, which would be 57. Over 4. And 57, I don't think we would be able to break that in. I don't think it has any factors that have a perfect square root. So I do believe that that's going to be it for number 1. I'll leave this here for a moment so you can give it a look. I'm actually just checking my work really quick while it sits there. And it looks like I did that correctly. Awesome. So again, looks scary, really not that bad. Let's move on to number 2. Number 2 is going to be handled exactly like number 1. The only difference is that we will end up with a complex number this time, so we'll have an imaginary number in there, square root of 1 somewhere, and they want it in the form a plus bi. And we'll talk more about what that form means once we get there, but I've got to go back up here because I never remember the quadratic formula. And I don't know why my iPad disappeared. Let's see if we can get it back really fast. That's going to take a second, so there it is. Okay, I was going to pause the video. Alrighty, so we've got x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And so as it's been in the past, this is our a term, this is our b term, this is our c term. Recognize that that b term is a negative 3, not a positive 3. And so that's going to get a little bit tricky because we'll have negative b, so negative 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times 2 times 6, all over 2a, so a is 2. So if we work on simplifying this, we've got now a positive 3 on the outside in the numerator, plus or minus the square root of 9, minus 4 times 2 is 8, times 6 is 48, over 4. And then x is equal to 3 plus or minus the square root of negative, what is that going to be, negative 39 over 4. And so now, since we've got a negative in there, a negative 39, we need to remember, I'm just going to do this over here on the side a little bit, that the square root of negative 39 is the same thing as the square root of 39 times the square root of negative 1. And negative 1 can be rewritten as I. So that will be the square root of 39i. And so, again, they want the form a plus bi. And so we'll talk about what that form means in just a moment. So x equals 3 plus or minus the square root of 39 I over 4. Now that is not the form that they're going to want. The form that they're going to want, when they say a plus bi, they want us to write this as one fraction, and they want us to write this as another fraction. And so, what needs to happen is that 3 over 4 is what we will consider our a term. And then the plus bi is going to be that square root of 39 over 4, and then the I gets written there in line with the fraction bar. And I'm just going to pause really quick and make sure that that's how Alex is going to want you to write it. I'll be right back. And so it does look like that's how Alex is going to want it. It looks like Alex might want you to split it into 2 separate equations instead of writing the plus minus like we've been doing, to separate it into both. And so I will do that as well. And so the answer there would be or 3/4 plus square root of 39 over 4, and again the I is in line with the fraction bar, and the other part of that being 3/4 minus square root of 39 over 4 with the I in line with the fraction bar again. And so again, the one that has the yellow and the green on it is an acceptable answer to me. It's the same as the stuff that's written to the right of that, but Alex is probably going to be picky with the way that you put the answers in there. All right, on to number 3. So number 3, there is this thing called a discriminant. And I'm going to use this to help me remember the quadratic formula again. And we'll talk about what the discriminant is in just a moment. So x is negative b plus or minus the square root of b squared minus 4ac over 2a. And so the discriminant is this piece inside that square root symbol. And so we can say that that right there is the discriminant. And there's a trick that if the discriminant is larger than 0, let's do this. If the discriminant is greater than 0, you will have 2 solutions. Now let's think about the reason for that for a moment. You're taking the square root of a number that's larger than 0, like the square root of 4. That's going to have a positive 2 and a negative 2 as a solution. The discriminant is larger than 0, you have 2 solutions. If the discriminant is equal to 0, you will only have 1 solution. Because if that stuff inside the square root symbol is equal to 0, 0 only has 1 square root. There's no such thing as positive 0 and negative 0. There is only 0. And so the solution would end up being just 1 solution, because what would come out of that square root symbol would be a 0. And then lastly, if the discriminant is less than 0, you will have no real solutions. And the reason for that is if the discriminant is less than 0, we are taking the square root of a negative number, and so we are going to end up with imaginary solutions or complex solutions, not real solutions. And so all that we are asked in this problem to do, we are not asked to find the solution to this quadratic, although I may go ahead and do it. We are just asked to first identify what the discriminant is. So I don't think I'll find the solution, I'll just find the discriminant. So the discriminant is b squared minus 4ac, again, just that piece inside the square root symbol. And just as it's been in the past, this is our a term, this is our b term, this is our c term. And we have our b term is negative 6 squared minus 4 times 5 times 3. So we're just plugging the numbers in for the discriminant just like we would if we were doing the whole quadratic equation. We're going to see if the discriminant is greater than 0, equal to 0, or less than 0. And so negative 6 squared is positive 36. 4 times 5 is 20. 20 times 3 is 60. The discriminant is negative 24. So if we go back to our rules that I wrote in green there, the discriminant is less than 0, so there will be no real solutions. Pardon me. And so the number of real solutions is 0. So again, we're not looking for what the solutions are in this particular problem. We're just learning that we can use the discriminant to determine how many real solutions we would have if we were to solve that quadratic. I'm going to pause for a moment and be right back. Okay. We'll clear some of these windows out of the way for us. So, all right. Moving on to what I believe is the last problem in this homework assignment. Yep. We have the wonderful word problem, everyone's favorite. And so a model rocket is launched at an initial upward velocity of 195 feet per second. The rocket's height in feet after t seconds is given by that equation. Find all the values for t. Find all the values of t for which the rocket's height is 87 feet. Run your answer to the nearest hundredth. And so to start off with, we're going to replace h with 87. So I'll copy the problem first. And so the height is 87. And so I believe we're going to need to use the quadratic formula to do this. And so what I think we need to do first is get that left side set equal to 0 so that we would have an a term, a b term, and a c term. And so I'm going to subtract 87 from both sides. And then at the same time that I do that, I'm going to write it in ax squared plus bx plus c form. So I'll put my squared term first, negative 16t squared. That's my a, plus 195t. That's my b. And then my c will be minus 87. And so I'm going to call up something from Alex that will have the quadratic formula in it for me because, again, I choose not to memorize the silly thing because I know I can find it. So we've got our a term is negative 16, b is 195, c is negative 87. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And so our b term is 195, so x is equal to negative 195 plus or minus the square root of b squared, so 195 squared, holy cow, minus 4 times negative 16 times negative 87. Holy macaroni, those are big numbers. Over 2 times a, 2 times negative 16. And Schlegel's going to be honest. Schlegel's going to use a calculator to figure out some of those things because I really don't feel like doing that by hand, and I hope that you do the same. I'll be right back after I do some calculation. All right, so I went ahead and did some calculations, and that's what my calculator gave me was 195 squared was 38,025, and then 4 times 16 times 87 is 5,568. It is negative because I have an odd number of negative signs there. And then a negative 32 in the denominator. So we'll continue with this thing. I've got 38,025 minus 5568. The discriminant, or the piece that's inside the square root symbol there, the radical, is going to be 32,457. And all of that is over negative 32. And so that is really something. There's no way that we're going to list all the factors of 32,457. And so I think what Alex is probably going to do is Alex is probably going to provide you with a calculator for problems like this. Let's take a look at an example. And at the end of the thing, yes, I think so. So you will come up with two solutions like this that have ridiculously big numbers. And Alex will give you a tool like a calculator or something to be able to find the approximate value of those numbers. And so let's come back to our work, recognizing that Alex is going to want this written as x is equal to negative 195 plus the square root of 32,457 over negative 32, or negative 195 minus square root of 32,457 over negative 32. Now, you'll be able to run those numbers into a calculator and come up with decimal approximations. Looks like Alex is going to want you to go to 2 decimal places, and so I'll do the same. I'm going to punch this in a calculator, and I'll be back with what I get. Okay, I got my calculations done, and the decimal approximations of those are 0.46 for the one on the left and 11.72 for the one on the right. And so putting that in context, it was the values, feet, time, seconds. So the rocket will be 87 feet off the ground. Both 0.46 and 11.72 seconds after launch. And this is because at 0.4246 seconds, it's going up and passes 87 feet on its way up. And then at 11.72 seconds, it's been on its way down and it passes 87 feet of height on its way down at 11.72 seconds. I do believe that's going to be it for this assignment today. Thank goodness. This is a bit of a haymaker, but I hope this is helpful, everyone, and I hope you have an awesome day.